Welcome to AI for GIs, Introduction to Artificial Intelligence. This is Module 1, Foundations of AI, and Class 3, The History of AI. ChatGPT, Gemini, Grok, and Claude did not appear from nowhere. The AI systems reshaping military operations in 2026 rest on 7 decades of research, false starts, and breakthroughs. Understanding this history reveals patterns that repeat, explains why certain capabilities exist today, and prepares leaders to anticipate what comes next. This class traces AI from its academic origins in 1956 through 2 periods of collapse called AI winters, the deep learning breakthrough that changed everything in 2012, and the transformer architecture that made ChatGPT possible. By the end, you will understand how AI evolved from theoretical curiosity to the systems now influencing military decision-making at every echelon. I'm Dr. Justin Webb. Let's begin. Here's what keeps leaders up at night. Modern AI systems like ChatGPT, Claude, Gemini, and Grok are now influencing military decision-making at every echelon, and most soldiers using them don't know the history. 7 decades of research reveals patterns that repeat. AI has already crashed twice before. 2 complete boom-bust cycles that destroyed funding, bankrupted companies, and sent researchers fleeing. Understanding those failures prevents us from repeating them. And here's the game changer. AI fundamentally shifted from programmed rules to pattern recognition. That shift explains both why it's so powerful and why it fails in ways you wouldn't expect. Let me show you the roadmap. This journey has 5 critical chapters. 1956, AI gets its name at the Dartmouth Conference. The field is born with massive optimism. 1974 to 1993, the money disappears. 2 AI winters freeze funding and trigger commercial collapse. Researchers abandon the field. 2012, AlexNet changes everything. The deep learning revolution finally ends the winter. 2017 to 2022. The transformer era begins. GPT-3 reaches 175 billion parameters, and scaling becomes the new religion. 2023 to 2026, right now, the agentic AI era. Autonomous systems are actively reshaping military operations as we speak. Before AI had a name, Alan Turing was already asking the question that would define the field. 1947, Turing delivers a lecture on machine intelligence. The term artificial intelligence doesn't even exist yet. 1950, he publishes Computing Machinery and Intelligence and proposes the Turing test. This single paper establishes conceptual frameworks that guide AI research for the next 7 decades. But here's the clever part. Turing didn't ask, "Can machines think?" He knew that question was philosophical quicksand. Instead, he asked, "Can machines pass as human in conversation?" A testable, practical question that researchers could actually pursue. Summer 1956, John McCarthy organizes a conference at Dartmouth and coins the term artificial intelligence. AI officially becomes a field. The researchers gathered there believed something astonishing. Human-level AI was achievable within 1 generation, maybe 20 years, 30 at most. They were spectacularly wrong about the timeline. Their optimism was premature by half a century. But here's what's wild. The core vision they had, it eventually came true, just through approaches none of them anticipated. The lesson, they underestimated the complexity of human intelligence by orders of magnitude. 1972, a mathematician named James Lighthill submits a report to the UK government. It's devastating. His conclusion, AI has failed to deliver on its promises. Period. The response is immediate and brutal. Drastic government funding cuts across multiple countries. 1974, the first AI winter begins. Research funding freezes solid. Graduate students flee the field for anything that pays. This establishes a pattern we'll see again. Inflated expectations collide with under-delivered results. The hype cycle completes. The field collapses. History repeats. Late 1980s. Expert systems are the hot new thing. Companies pour money in. Then reality hits. Expert systems prove brittle, expensive, and impossible to maintain. Commercial AI companies start going bankrupt. The market collapses. 1993. The second AI winter ends. The field has now experienced 2 complete boom-bust cycles. Same pattern, different decade. AI hype leads to failed delivery, which triggers funding collapse, which causes exodus from the field. The term AI winter becomes shorthand for when research funding freezes completely and careers die. If you're keeping score, that's 2 catastrophic failures in 40 years. 2012. Everything changes at an image recognition competition. AlexNet enters the ImageNet Challenge and achieves a 15.3% error rate. Second place, 26.2% error rate. That's an 11 percentage point margin. To put that in perspective, in the history of this competition, no one had ever seen a gap that large. This wasn't incremental improvement. This was a different kind of system demonstrating clear superiority. AlexNet proved deep learning could solve problems that resisted decades of alternative approaches. The winter ends. Within 2 years, every major tech company on the planet is investing in deep learning. Google, Facebook, Microsoft, Amazon, everyone pivots. So what made 2012 different from the 2 previous failures? 3 factors converged at exactly the right moment. Factor 1, vastly larger data sets. The internet had created mountains of training data that didn't exist in the 1980s. Factor 2, GPUs. Graphics cards designed for gaming proved ideal for the parallel computations neural networks require. Gamers accidentally built the hardware AI needed. Factor 3, algorithmic improvements that enabled training deeper network architectures, smarter math. Here's the critical part. Convergence was necessary. None of these factors alone would have succeeded. You needed all 3 at once. The result, dramatic improvements across computer vision, speech recognition, and natural language processing. AI finally started working. 2017, Google researchers publish a paper that changes everything about how AI processes language. The transformer architecture. The key innovation, self-attention mechanisms that process all words simultaneously instead of sequentially. Previous models read text 1 word at a time, like a human. Transformers see the entire sentence at once. This unlocked dramatic scaling. More parameters meant better performance. You could just make the model bigger and it would get smarter. Every modern conversational AI you use, ChatGPT, Claude, Gemini, Grok, they're all built on this architecture. This single paper is the foundation of the AI revolution we're living through right now. 2020, OpenAI releases GPT-3, 175 billion parameters. That's approximately 100 times larger than GPT-2. This proves something remarkable. Transformer performance improved with scale. Just keep making it bigger and it keeps getting better. No plateau in sight. But here's where it gets interesting. Larger models showed emergent capabilities that smaller versions didn't have. Abilities that appeared seemingly out of nowhere when you crossed certain size thresholds. Skills the researchers didn't program. GPT-3 set the stage for the breakthrough that would come 2 years later. The world just didn't know it yet. November 2022, ChatGPT launches to the public. The response is immediate and massive. Millions of users within weeks. The adoption rate is unprecedented in technology history. Faster than the internet, faster than smartphones. For the first time, the public has direct access to transformer-based conversational AI. No technical knowledge required, no special access. Just open a browser and talk to it. The shift in perception is instant. AI moves from future technology to present reality overnight, and that triggers rapid acceleration in military and enterprise adoption. Everyone suddenly realizes this is real. 2023 to 2026, we're living through the next evolution, the shift from responsive AI to autonomous agentic systems. These aren't chatbots anymore. They browse the web, they write and execute code, they coordinate across multiple systems with minimal human guidance, they take action. The military is already integrating this. Ask Sage, the Army's Palantir ecosystem, running intelligence, logistics, and administration. These are operational systems, not experiments. We've also hit multimodal, processing images, audio, video, and text simultaneously. And here's what's new. These systems reason through problems, explain their thinking, acknowledge uncertainty, and admit when they don't know something. That's a fundamental change in how AI behaves. So, what do 7 decades teach us? First, pattern recognition. AI has crashed twice before. Both times followed the same cycle: hype, failure, collapse. History provides the playbook for managing current expectations. Are we in another hype cycle right now? Maybe. Second, paradigm shift. Modern AI uses statistical pattern recognition from massive datasets, not programmed rules. Understanding this explains both why it's powerful and why it fails in specific ways. Third, acceleration. 12 years from AlexNet to autonomous agents. 2 years from GPT-3 to ChatGPT. The pace suggests continued rapid advancement, not stabilization. Fourth, inherent limitations. Training data biases, inability to know recent events. These are fundamental to how the technology works, not temporary bugs to fix. Fifth, military imperative. Understanding this history is essential for anticipating future developments and making informed decisions about AI in military applications. Here's the bottom line. AI's 70-year journey from Dartmouth 1956 to military operations in 2026 reveals patterns that are critical for leadership decisions right now. The systems you're using today represent the culmination of two AI winners, the 2012 deep learning revolution and the 2017 transformer breakthrough. This didn't happen overnight. The fundamental shift from programmed rules to pattern recognition explains both the power you see and the limitations you'll encounter. Understanding that shift is not optional. Manage expectations carefully. The pace from AlexNet to ChatGPT took 12 years. That suggests acceleration, not stabilization. More change is coming. For military leaders, understanding this history lets you better anticipate, adopt, and manage AI capabilities at every echelon. The leaders who know this history will make better decisions than those who don't. Now you know the history. Next question, what can these systems actually do? Class 4 covers AI capabilities. We'll explore what modern AI systems can and cannot do, and how to apply them to military decision-making. The practical stuff you need to make informed decisions. Don't wait for the next class to keep learning. Stay connected with AI for GIs on TikTok at justin.webb, Instagram at pstrategus, YouTube at webb8020, and LinkedIn at tjustinwebb. Daily insights on AI and military applications. Visit the full course at pensader-strategus.notion.site/AI-powered-strategic-thinker. I'm Dr. Justin Webb. Thanks for joining me for AI for GIs.